Hi, folks, and welcome yet again to another edition of Helium Hacks Happy Hour. My name is Travis. I go by TT over on the Discords, and I will be your host today. So, we got a cool show today. I'm excited about this. Nathaniel from over at Hivemapper is joining us to be talking about the project. If this is your first time, just real quick, everyone, this is a very casual show. Everyone is invited to unmute your mic, turn on your video camera so we can see your pretty faces, jump in, introduce yourself, and let's chat. But we want everyone to kind of get to know one another off of the Discords, outside of just a handle and an avatar. So, but that being said, if you're not actively talking, we don't want to hear conversations going on in the background or whatever else you have going on. And also, if you're not going to be sending a video feed or not using a camera, turn your feed off so it doesn't get up in the editing. It just kind of mucks up editing. It makes it a little more of a pain to edit down. But if there's any project you want to share, if you want to present on the show, if you want to talk, just hit me up, and we can discuss that. We can lock down a time slot for you, and we'd love to hear about what project you're working on. We do have a community project that is in progress right now, private text messaging type hardware device. And if you're interested in that, please jump into the Helium Hacks Happy Hour channel over on Discord, and let's talk about it. Oh, we also give away Helium developer kits here, which are based around the Wrap WizBlock ecosystem. And so if you're looking for some hardware to develop a project with and to hack around on, a lot of us here in the community use these things. But let's get going here. Nathaniel, thanks for joining us, man.
Hey, thanks so much for having me. Really exciting to be on the show. And, just on a personal note, I'm super excited to hear about the text messaging application. I've chatted with Joey a couple times about it. That's in my free time, I think about different ways to send text messages. So super excited to hear about that project and looking forward to following along in Discord with that.
Yeah, there's a video where we talk about it a little bit, or two videos, I think, up on our YouTube playlist. So Hivemapper.
Great. Let's get into it. Yeah. So again, thanks for having me. Super excited. There's a lot of different things, I want to get into today. Clearly there's some excitement around the first version of our camera, the Raspberry Pi HTC. We'll see if we can get this into frame. We'll talk about that a little bit. I do have the next version, the HTC S, with me here today, so happy to talk about that a little bit. We can cover a lot of exciting stuff there, and some of the hopes and dreams and aspirations we have as well. So excited.
So, for anyone who hasn't heard about the Hivemapper project, can you give us just like an overview of what exactly, what's the goal here? What does this project aim to do?
Great. Okay. So, let's start off with sort of setting the framework for what we're trying to do as an organization. So, basically the concept is what if more than just, say, Google mapping vehicles had the ability to create a map? Well, what if we gave that ability to the community? What if we decentralize this? And so it's decentralized in a couple ways. So what if collection of map data was decentralized? And what if ownership or access to that was run differently than it is today? And so those are some of the ideas that gave rise to Hivemapper. And because imagers and cameras are so much better than they were when Google Maps started, or any of the incumbents for that matter, because they're so much cheaper, there's a technological change that's happened that allows us to do all of this. So the goal is ultimately, here's the punchline, is to build the world's best map. And we think that the way to do that is decentralization. So that's what we're after. Happy to talk about some of the basics of how it works as well. Would it be a good time to go into that?
That sounds great to me.
Okay.
You're running the show. Anything you want to talk about? Let's go.
Anything I want to talk about. Okay. So the Hivemapper Dashcam is fundamentally built around Raspberry Pi platform. So basically what we do is we have an imager on board, and we collect images, we collect location, and we collect timestamps. Timestamps are really, really important for what we do. And so when we match up location to images, And that gives us a picture that we believe is in a specific location, looking in a specific direction. So that gives us the basis to start doing some cool things and ultimately building a map. So, building a map could mean a lot of different things. And so let's get into the types of applications we're trying to power. So, you know, if I want directions to go to a Waffle House, you know, that's pretty well covered, right? That's pretty well covered. I can get onto whatever mapping application I want, be it Apple or Google Maps, and get directions there. But there's a lot of other interesting things to do with maps, and I mentioned that up front because that's a question that everyone has, right? So we already know how to get to that place. What else are we looking? We're looking to do things like detect new street signs, changes in road conditions. We're looking to find stoplights. We're looking to see if there's road damage and changes in route. So there's things that happen that are permanent, and there's things that happen that are temporary. So emergency vehicles are temporary. Changes to routes are permanent, and typically that means new roads, but roads can be closed as well. So there's all sorts of famous examples that some are serious and some are humorous. Serious ones have been tales of roads that dead end into a lake, right? So we've heard of some of these stories over the years. So having the ability to look at these images and apply computer vision techniques to understand what we're looking at allows us to build features around a map. So again, automatic detections of signs. It could be exit signs, stop signs, speed limits, but then also road obstructions, emergency vehicles, and stuff like that. So all that's done. All that's done with a combination of the dash cam that we're going to talk about here in a little bit, a phone. So today we do require that you have a phone involved, and some backend processing that we do in our AWS infrastructure as well. So I'll pause there. Any questions? Any questions from the audience so far about sort of what we're up to and why we're doing it?
There's a question. I don't know if you have text up over there.
I do. Oh, I love talking about LiDAR. Okay, so we'll talk specifically about LiDAR, and then let me talk briefly about the sensors we do have in the device. So LiDAR is getting increasingly cheaper, and so we're looking forward to having LiDAR support in the future. We aren't integrating LiDAR today, but super excited to do it down the road. So let's talk a little bit about what is rolled up inside the camera. So, one of the obvious sensors is we have an imager. It happens to be, an ArduCam based imager. It's for those who are interested, it's an IMX 477, and don't ask me too any other specs inside the device. That's one of the ones that's easier to remember. But we do also have IMU, and of course we have LoRaWAN on board, so we can do awesome stuff like connect to Helium, and we'll talk about that in a minute. And we have GPS. So I mentioned location data was important. We have u-blox M9N, standard precision GNSS chip. Yeah, those are sort of the critical pieces to talk about. Coming back to the IMU and GNSS very briefly. So, as much as LiDAR is interesting, because we have so many people driving, we get lots of shots on goal to see a particular feature. LiDAR is really, really interesting to precisely measure your distance to an object, and super critical for self-driving vehicles. For what we're doing, we have an opportunity, because we have multiple shots on goal, to do 3D reconstruction. So we can establish where an object is using 3D reconstruction techniques offline, right? So we don't have the real-time need to know precisely our distance to a particular object, because again, we're focused on mapping. However, that said, that data is still super interesting. Really looking forward to including that in the future. The HDCS, so this is the other cool device I'm holding. Super excited about this. There's actually two depth sensors. depth sensor on either side, and then main imager in the middle. And so we get some different ability on the HDCS in terms of hardware with that regard. And so right now, our platform is really based around those particular data sets. We are expanding with the depth sensor on HDCS. LiDAR definitely in the future. And there's some other interesting technologies as well that we're interested in supporting. But basically for the version 1 of our platform, we wanted to get off the ground with something really consistent. And part of our excitement is just building an open ecosystem that will allow us to bring on board different sets of data like that. So looking forward to that down the road.
You would mention the IMU that was on board, and I know initially you didn't support, I guess, two-wheeled vehicles, but you held a contest recently, right?
Yeah. Let's talk about the two-wheeled. Yeah, let's talk about the two-wheeled vehicles. So, two-wheeled vehicles are interesting for a variety of reasons, right? There's a lot of them. People have some desire to map when the vehicles are on. There's definitely some challenges as well. So we do have a QA system. So part of our goal is to support two-wheel vehicles. Really does increase the volume of QA we'd have to do on that data. So typically the failure mode there is you're on your bicycle, you're in a turn, you're tilted, and now all of a sudden the image is rotated. And so IMU data does help us detect some of that. And so our automated detection system is set up to filter some of that data out. So, there is some good usable data from a two-wheeled vehicle. It's just right now, it's going to be less. But with that said, if anyone wants to mount a gimbal onto their bike or motorcycle, we'll be able to accept more of that data. But yeah, we have to use IMU filtration there. And then, as I mentioned, we do have human in the loop QA to check some of those images as well. People are mentioning that more stabilization is needed for two-wheel vehicles. The other thing that people commonly ask about is just carrying the dash cam around. And I have to be totally transparent. Though we don't encourage this for mapping, we have to test at work. And so we can be seen walking around San Francisco with motorcycle batteries in our backpacks, holding dash cam. So not a supported mode for mapping, but it definitely does produce data. So cool. All right. So I did also want to talk a little bit about the decentralized sort of implications of having an open platform. So I mentioned we have GNSS, and I also mentioned that we have LoRa on board. So part of the challenge of having an open platform like we do is, we really want other people to start producing their own Hivemapper Dashcams, and there are actually a number of people who are in the process of early phases of the process of building their own. So that means that we have to have trust mechanisms in place, right? So we don't want people doing things like GPS spoofing and putting their dash cams in front of monitors with cool pictures of roads, right? We don't want to start accepting junk into the network, and so having LoRa on board and the ability to connect to Helium is really important for us because we have another independent signal on location. So as you're driving around, and there's a blog post that we put out almost a year ago that talks a little bit more about this. But as you're driving around, we do observe what Helium hotspots are nearby. And so that gives us a new set of signal in addition to the GPS from the device, and also in addition to GPS from your phone that allows us to independently verify. So Helium is really an important part of our network today. So we're really happy to have that ability. There is some excitement to do other things with the LoRa chip on board. I've had some ideas around hacking there. So having Hivemapper Dashcams communicate with each other is something we've talked as a fun hack idea. we don't think that will be something that we implement in production, right? We don't necessarily want dash cams communicating with each other out in the wild for privacy reason. But there's a lot of fun possibilities there on the hack side. So looking forward to opening up a hack in the future where we set up dash cams to communicate.
Oh yeah, no, that would be super cool. And
Yeah.
because there is jumping on the hardware real quick,
Yeah,
there is a USB port, a USB port on
sure is.
cams.
Yep.
And it supports a particularly format of memory card, and so I can save down, I guess, images onto the device.
Yeah, that's right. Yeah, it still works as a dash cam. If you plug in a USB stick, and it's formatted in FAT32, you'll start saving images.
But yeah, just thinking about the LoRa radio, it would be cool if I could, kick that over to an integration I have that just tells me what frames or what files, I flag or I mark that I want to, I want to pull off the thing without having,
Totally.
drag through all of the data.
Yeah. Yeah, part of the open platform is we want people to be able to play and hack with their devices. The firmware is based on build root. You can make your own build root and flash it over, and your Hivemapper Dashcam will do different things. So it is totally possible to make your dashcam do different stuff. You can also today in development mode SSH into your dashcam. So that's a thing as well. And yeah, you can pop in and interact with it in any way you want. So part of the open platform is we do encourage that. So talking a little bit about more what we can do with LoRa on board. I had some inspiration recently. I was looking at a YouTube channel where there was some mesh networking for off-roaders, and so these folks were communicating their vehicle locations to each other. And I thought it'd be really cool to build a similar hack application, but on top of the Hivemapper Dashcam. And so talking a little bit more about the hardware, we use a LoRa board that Hellbender produced for us. It's fairly capable, and it operates at the upper end of transmit power. The certification house tells us it's within the appropriate range, in case the FCC is listening. Absolutely is. But yeah, it's a fairly robust antenna on that. And, if you're interested in hacking with that, it's a great way to have a Raspberry Pi, a Raspberry Pi OS with access to LoRa.
I had a question. So you have LoRa data where you've connected to hotspots in the area, but you also have GPS data too. So are you sharing that back with Helium so that we can map where our network is?
Yeah, the Helium Mappers program. Yeah, we do. So the process there, and I may tag Joey in to talk about this in more detail, but we do share back with the Helium Mappers program. We do that as a batch thing. So we have a special concern here about not revealing where people are driving, right? So that's really important to us. And so if we were doing that in real time, we'd be revealing people's location. That seems bad for everyone. So we push that data in batch, and it actually goes into a different mappers database initially, and there's some ETL that happens on it, and the goal there is to contribute to the Helium Mappers project, but also preserve privacy. So the short answer is yes, we're doing it, but we're doing it in a way that's respectful to everyone's location privacy.
Yeah, I don't think that really is real-time data in that case. It's not really that important. So
yeah,
that makes sense.
Yeah, and I think that was discussion is is real-time data super critical there, and it seems less sensitive for now. Yeah, but we're super excited to be contributing towards that, and especially with the mobility of the dash cams, people are driving all over the place. So it seems like a high volume, high quality signal. Cool. Thanks for the question. So there's a question on what RF bands are we mapping? Could I get more clarity on that question?
Yeah, I was just wondering. I mean, you mentioned LoRa, but is it like Wi-Fi? Are you mapping mobile?
Yeah.
And what's the whole gamut that you're doing there?
Yeah. So we're really doing two types of mapping. So one is object detection. So object detection on camera images, that's one type of mapping. In the second type of mapping is LoRaWAN mapping. We're not doing Bluetooth or Wi-Fi mapping today. We've definitely been approached by people who are interested in Bluetooth and Wi-Fi mapping. We have some interest in that. I think there's a question of like human hour bandwidth in order to do that. But we have some interest in that as well. But we do, since we play with phones right now. There's some amount of that happens already on mobile devices, whether it's Android or iOS. So you get some of the synthesized signal from that for free if you're also leveraging location data and apps. But yeah, I think long term, there's a couple different people who are interested in us posting to a mapping API. So we may consider that down the road.
Because the data's already there. You're driving by. It's in the air.
Yeah, it is. It absolutely is. Yeah. I think Wi-Fi and Bluetooth are really interesting for those. To do mapping of that as well.
Cool. Okay, thanks.
Yeah.
Do you get around most of the PII issues just because the person who's really giving you the data, they sign off on it when they they sign your terms of service?
It's more than that.
But everything else is just up in the air, right? I mean,
it's more than that. So everything. So once you put a radio signal in the air, there's a different set of rules that governs it. But you can certainly, you're allowed to observe what Wi-Fi networks you pass by. So that seems okay. In terms of the PII aspect, I think that really comes in to play with a person who's driving. So the person who's operating the camera.
Okay.
So we spend most of our time focused on thinking about things that preserve their identity and security. But yeah, there certainly are considerations about observing other locations. So there's so many different types of observation here, right? So we've thought about Wi-Fi and Bluetooth. Also, like what happens when I drive past a military base? Now I'm taking images of like a military base. Some of that stuff can be restricted. So there is some geofencing that's interesting to talk about. And so there's on the U-Blocks M9N, we do have the ability to do geofencing to shut off location data there, which shuts down the rest of our data ingest system. So unless we know where the device is, we actually don't want to capture signal. It's really critical for us to know where the device is in order to capture signal.
right?
Yeah.
I mean, there's some private residentials here nearby me where Google Streets it's just blurred. It doesn't matter what pass, that house is always blurred. And is that something that you deal with where you have complete, do not fly zones that you have to just wash the data on?
Yeah. So we have certain places we're not allowed to map. So absolutely. We haven't had, to my knowledge, and so this isn't my particular wheelhouse. So, if I've overstepped, I'm sure somebody on my team will let me know later. But I don't believe we've had particular requests from private individuals. But I could certainly imagine if we map the private home of a politician or a celebrity, I imagine those requests could come in. But to my knowledge, we haven't had any individual requests. We have had guidance on sort of larger no-fly zones. So there's particular countries that have different regulations around this, and so it's really important to us that we're respectful of local laws and regulations. And in some examples, there's countries that require you to keep the data in a data center effectively within the country, and so those are some of the compliance rules. There's other things we do around privacy masking as well, so automated blurring of images. But in terms of individual requests from private people, I don't know that we've had those yet.
Gotcha. Thanks, man.
Yeah. And that's kind of an exciting idea, though. It's kind of an exciting idea that you get to the point where that's a particular consideration. So looking forward to that phone call.
Another question for you. I'm sorry. I'm gonna
Yeah.
them.
Yeah, great.
Now, we've heard recently that I guess what Ring has pulled without warrants footage from individual Ring owners for help in tracking down a crime.
Yeah.
Whether, I don't know the legitimacy of that or not, but we've seen that it has happened. It has occurred. Is this something that you deal with on your end?
Yeah, great question. Great question. Yeah. We haven't had any request of that nature. And so, if we got a request like that, I'm sure we'd have to consult the legal team to see what the right thing to do is. It is important to note that we do mask faces when detected. So there's some goal of privacy blurring, and I've had questions before, around turning over data to governmental organizations from candidates and other people at other speaking engagements that touch on the same topic. And I'll speak to my personal viewpoint on this, which is like I love the idea. I love the idea that you could help somebody in need, but the thing that seems really scary and risky to me is how do you make those individual moral determinants for each data request? And so I think our position on this is to preserve privacy as much as possible, because ultimately we're not we're a mapping tool, so we're designed to help people find street signs and traffic lights. We don't for the foreseeable future want to be engaged in crime fighting. So I know that's a bit of a roundabout answer, but it hasn't been requested yet. And if it does, I think we'll have to look at the specific case when it comes up.
Sure. Good.
Yeah, totally. Yeah, I think the news in the conversation about Ring is really, really interesting. And, I personally don't have a Ring camera anymore. So, yeah. Yeah, so one thing I'm also super excited to talk about is sort of the challenges of engineering high quality performance on GNSS in a particularly noisy enclosure like we have in the HDC. Would folks be interested in talking about some like RF engineering? Is this going to get too weird?
I
go deep?
That would be too weird at all.
Can we get deep? Let's go deep on this. Okay, so I would say that I've spent maybe most of my time over last year thinking about ways to test and validate GPS and how to continually design better boards. So we've released the Hivemapper Dashcam, and sort of behind the scenes we've continued to think about tuning that performance. So I have one of our early test devices with me, and I'm not sure how legible this text is, but we have some painter's tape on the top with notes about the tuning network for the GPS antenna. We've tried out different GPS antennas. We ended up with a TwoWheel surface mount antenna. There's a couple reasons for that. The first is that you don't have to snap a cute little UFL clip onto the board, which is a manual process. And if anyone's played with UFL connectors before, they're fragile and they're kind of a nightmare. So that was our goal. The initial tuning of that was super challenging. And the reason it's challenging it is because we have a camera with a big old connector which acts as an antenna. So you have a noisy camera, you have noisy CPU. Presumably there's some noise from the LoRa board as well. And so, you have all these noisy components, and we spent a lot of time tuning and modifying that. And so we ultimately, we're producing a 6-layer board. The extra shielding in the board has been super helpful. And we do have, current production is using that TwoWheel SMT antenna. And so we can take a look at that. I think I think this particular device here is actually a UFL patch antenna. And they're great in some circumstances, but we've actually noticed different on the ground behavior between the two of them. The larger patch antenna is a little bit more sensitive to how we use the CPU. And the Tau glass antenna seems to be a little bit less sensitive. And so we have to do a lot on the software side in order to make sure that we keep all the devices out there behaving correctly. So that was quite a challenge. And then the other thing that's challenging is coming up with good benchmarks for GNSS. And so we've done a lot on the Hivemapper side, but Hellbender, who's produced the first one, has also done a lot of analysis and testing. So we have a GNSS test chamber to throw devices in and simulate signals. And you think you could come up with a good test for a device in there, but then you take it out in the real world, and the real world is different than a test chamber. And so we've settled. We have some tests, some static tests. We have some driving tests. We look at a number of different statistics. If there's any GNSS nerds on the call, horizontal dilution of precision is a really important metric for us. Time to first fix is interesting as well. But we look at horizontal dilution of precision continuously in our testing, and so getting that down to reasonable levels while we have this really noisy imager and CPU happening was a significant engineering effort. We also had to do the same thing with the HDCS. So I wish I had an open HDCS, but the bottom of this HDCS is a big piece of aluminum. And I actually have a heat shield on it right now, so it's harder to see. But this big piece of aluminum was originally designed as a reflector for GNSS signal. And so in addition to reflecting GNSS signal, it's also reflecting some noise from some of the other components on the board. So in that process, we've ended up, it is a 6-layer board as well. We've discussed going to 8, but we ended up extending the board to touch the edge of the housing, and in fact overlap a little bit to make sure we have effectively a bit of shielding from that board. The antenna on this one is actually placed back here to keep it as far away as possible from the imager. The HDCS has the best performance so far in early tests. Those aren't the final word on testing. So we've produced just about 8 of these so far. There's another 5 that are in production today. We'll have a number more into next week, and we're ramping up production from there. So testing is TBD on GNSS quality. There may yet be some tuning to do, but significant amount of effort in order to get that all working correctly. Yeah, RF is voodoo. So love that comment. We have like RS test labs looking at this. We've got electrical engineers at Hellbender have looked at it. Electrical engineers on the Luxonis side. Luxonis designed the HDCS for us. And it's just, it's a huge team effort. There's a lot of people working towards tuning it and making it better. So one of the other things I'm super, super excited. Yes. Are we ready to cut it open?
No, we can. No, let's finish up here. Let's keep talking. I just wanted to throw that in there.
One of the other things I wanted to talk about really quickly is, a lot of people ask why we can't just map with a phone, right? Like this is the question I get most often. It's like let me go off and buy, I could buy a $200 or $300 Android phone and map with it, right? They get really hot. So the answer is they get really hot and they'll shut down. So that's a problem. But these dash cams also get hot. So I don't know if folks have noticed, but there's actually a gigantic heatsink on the back of the HDC. In the entire bottom of the HDCS's heatsink, there's a fair amount of mass to this thing as well. So part of the engineering challenge here is just figuring out how to get enough heat away from the HDCS in particular. In addition to all the RF engineering challenges, doing something like this without a fan, I mean, if you throw a fan in there, you're good, but then you lose your weather sealing. So they're both IPC rated. We have dunk tested them. So that's exciting as well. the idea behind that is we want people to put them on top of their car, and things get wet up there sometimes. So at any rate, I'm excited to cut it open as well.
Yeah, they're not easy to get open, folks. By the way, like you said, they are completely weather sealed. With I guess like potting epoxy or along all
You
seat.
got it. They are epoxied. Can I say one note on your ability to get this open? So Travis is the first person to get an HTC open without sawing it. At the factory, when we have to do rework, we put them on a bandsaw. So I'm really excited and impressed that you were able to get it open.
It took a little time, but yeah, it was able to get it apart at the seams through the epoxy.
Cool.
Hey, you figured out a new rework method, Travis.
Yeah. I immediately contacted friends at Hellbender and let them know that it was possible.
Yeah. Now it wasn't completely without casualty, however, because it's not just the epoxy on these,
Yeah.
but the mechanism that you have a dual board in place with it has some pins that are surface mount, and surface mount pins are kind of notoriously,
Yeah.
flaky when you're messing with them, so you don't pull the traces off, when you get a little pressure against them. So. But yeah, that epoxy, I did want to ask what kind of epoxy you were using there, because I've got to get some of that stuff. It's it's good stuff. Yeah.
I will tell you, I don't know the epoxy off the top of my head, but I will tell you what it is. And whatever they're using is better than that JB Weld I've been throwing on things at home.
Oh, I believe it. Yeah, absolutely. And is it a two-part?
It is a 2-part epoxy. Yep.
Yeah, it was good stuff. The only thing that I got out of this one, it was a little brittle. It was just too hard, and that's what I believe spared me from. I was ready, and Jason knows. I was talking with him that day, and was about ready to pull out the Dremel. It was really close there.
We've actually whipped
Down a while.
Was it more like a kind of like a super glue where it kind of melted both sides of the plastic? No. Yeah.
I mean, it looks like, as I guess once the two-part was mixed, it was poured just against the seam, and
That's right.
just against the seams. Yeah, but it was
right.
It was on every seam, man.
Yeah, you got the materials engineer side of me like peaked right now. So
Yeah. And we've actually experimented with different amounts of hardener for that particular epoxy. In one of the early prototypes, it wasn't quite hard enough. So, I was actually really curious about your feedback around the epoxy being brittle. So that was something we did pass on to Hellbender as well.
Cool.
Do you have the components of this torn apart HTC there in front of you? Wow. Love it.
I do, and so this is put back into the case, and so you can see the layout here. Maybe. And so this board comes out. I can pull this cable real quick. Okay. And then on this side, this is the power board.
yeah, that's the MIPI connector right there for the camera.
Yep. That's right. Yeah. Yeah, that's the carrier board.
And this connects with these pins right over here, these surface mount pins, onto the board it's surface mounted to the board underneath. And then this whole board comes off to reveal a dual socket Pi on the other side of it.
That's right. Yeah, board-to-board connector CM4. Is this guy broadcasting Wi-Fi you can see?
Right now, no. Well, I can power it right here. I can power it inside.
Yeah, I think full confession is we shipped you we shipped you a sick unit that wasn't broadcasting, but now that you have it apart, we could get you to reflash it and it would come back to life.
Oh, okay. Right.
Yeah.
Oh, and that's another thing I wanted to kind of mention here is you've got a number of test points on this
Yeah. Yep.
that are exposed that with pogos you can tie into.
Yeah.
And some of these bolts were very much underneath the epoxy, by the way, and so you didn't know exactly where the bolts were going to be.
Totally.
Fun too. But the epoxy went, you can see, all the way around this first seam, and then all the way around on the other side, which one side of the Hivemapper does not come off, the enclosure.
That's right. Yeah. And I believe the camera is glued in there as well.
Yes, there's a small lip around it.
Yeah.
Around the other side of the camera, yes.
Yeah. And the glue may just be on the lens, so it may pull out, but there should be some glue on the lens to fix the focus.
Right, and that stays in. I just left that in the enclosure.
Yeah. I've done that on my teardowns too.
But that does expose the sensor, I guess. So you have to be careful not to get that all dirty, I suppose.
Totally. Well, the biggest coin of caution on tearing one of these down is that tau glass antenna. Those things are so extremely electrostatic sensitive. It's hard to describe. It's hard to describe how frustrating they are to work with. So we definitely assemble these, of course, in a clean room. But yeah, during rework, if you touch that thing, you'll see what happens to GPS performance. I mean, it's just, dilution of precision just goes to the roof, and the thing will turn on and turn off, and it is a very sensitive component.
Well, that's why their antennas are so good, right?
Yeah, totally.
I'm a big fan of their antennas.
They're awesome.
And I just realized that I cannot take this board apart anymore because of the repair that I did on these pins. I can't.
Oh yeah.
Get to this. Yeah, I can't get to that bolt right there.
Yeah, for the tau glass, you're probably blowing the front end tuning
foil
on it.
Yeah,
you know what I mean.
Yeah,
that would be the sensitive input circuitry. That'd be the thing that would take the brunt force. So yeah, that'd be my guess. Yep.
I think that's
an easy way, because that's just capacitors, and like if you could tune them, you could actually repair them. But yeah, it's probably just capacitors and resistors.
Totally.
Inductor, maybe.
So we have our own tuning network on them. So we have a tuning network in front of it. In addition to that, it's like we've swapped that tuning network off and replaced it in rework to see if we could get them to come back to life.
Yeah.
There's also this little piece of foil on top of the antenna, which is cool to look at. And I think your tau glass is exposed there, if I remember correctly. But yeah, you'll notice the foil has little nicks in it, and so they tune the antenna by making little nicks in that piece of foil.
A laser or something, probably. Yeah. Or maybe. Yep.
Yeah, it's super cool.
Yeah.
Cool. Is that the IMX?
This is the camera?
Yeah. Our friend IMX 477. Also known as the Raspberry Pi high quality imager. There it is.
I guess for like the GPS, you're at 1500 megahertz. So yeah, you're looking at like picotofemtocoulombs of tuning. So it's pretty small at that point. Yeah. Okay.
Yeah. So this one I have right here is 1.8 pico. So that was the particular network. There's a couple caps on there as well, but yeah, definitely precision.
And so, yeah, when you're talking about, heat dissipation on this unit, I mean, there is no airflow. I mean, this thing is completely sealed up.
Yeah.
And this entire part on the back is, I mean, it's not a knob. It doesn't turn. There's, this is just a heat sink with fans to bleed heat out of this box.
We thought about making it longer. Yeah. We thought about making it longer.
Grab this out of your car when it's been sitting in the sun in a hot Texas day. Yeah, the thing holds heat.
It holds heat. It holds heat for sure. Yeah. The HDCS gets even hotter, which is why we have a plastic shroud on it. See if you can see it. But yeah, this extra shroud is like, we got this thing into thermal testing and it needed a shroud, so it is what it is.
Wow. And so when are those available? Or the new?
Yeah, so we've been taking pre-orders on them. Full rate production is scheduled to start around June 30th. We're fully ready to start. Getting the different parts has been an interesting supply chain management experiment. So right now we are waiting on cameras. So we're hoping for a small batch of cameras to come in the next week. So that'll let us build the next 30. And then for volume after that, we should see some cameras towards the end of the month. But yeah, it's just been it's a supply chain challenge to get everything. But yeah, we have a design that is production ramp up ready, and so we'll continue testing as we ramp up. But yeah, so long and short is it, full scale production is going to be underway by the end of June.
Cool. And I've seen a lot of people talking on Discord about mapping with a camera facing forward and then like a side view camera.
Yeah, side view camera.
Same vehicle.
That's a thing. That's a thing. Yeah. So, there's a part of our reward system, that covers route novelty. So, it's most interesting to map stuff that hasn't been mapped before, right? Is a great way to say that. And right now there's not a good way to detect people who have mounted, several cameras to one vehicle in real time. We notice in batches we process the data, but we do encourage people to have a front and a side mounted thing. We do not encourage people to have rear facing cameras today. IMU data would in theory let us know if one mapper has a large number of cameras connected, so we look for that. But yeah, forward and side mounted. Side mounted is great for getting fronts of businesses, parking restrictions, and things like that.
It'd be interesting is if you could, there's a lot of cameras on cars, especially like the Tesla,
Oh yeah.
There's usually a rear view camera on almost every car today.
Yeah.
But if you could tap into
a requirement
port and pipe those cameras in, I mean, that'd be kind of interesting. You wouldn't need the onboard camera, but you could take the feed like from the actual car because there's already cameras there.
I would love to. I would absolutely love to. So it's such a good idea. Really interested in doing it. That's really I would say the medium term. I'm not going to say it's long term. It's a medium.
It's like something that everybody comes up with naturally, It's like, but
It's like I've got cameras. I drive a Tacoma. I've got cameras all over the thing. It would be great to just pipe that data in. So yeah, that's something we're definitely thinking about. And we don't particularly see ourselves as being a hardware company, right? So we had to do something to get it up off the ground. And we're all engineers and hackers, and so we did the logical thing, which is to build a Raspberry Pi system, of course. But yeah, having something
that's a $20, $30 RG cam right there,
Yeah,
$20 off the bomb.
Yeah, totally. Yeah, those tapping into Tesla would be great. Looking forward to that. If anyone could get us an introduction with Elon, let us know.
Now you mentioned like new and exciting places to map. Can you explain the concept of regions?
Yeah,
Hivemapper?
yeah. So there's basically there's a couple ways to think about. Well, there's more than a couple. There's a couple relevant ways to think about how you divide up the Earth. And so one way to divide up the Earth is to say it's based upon political boundaries. So these are mapping regions, and so like let's say I happen to live in San Francisco, so San Francisco Bay Area is a particular region. There's some challenges with that. The way political regions are defined is oftentimes funny. You could be in an area that you consider part of that metro region, and you're actually outside. So it's not perfect. But mapping regions allow us sort of a human understandable way to think about where we're trying to grow coverage and where we do have coverage today. So it's a way to talk about it. The second way to talk about how to divide up the Earth is, through hexagons. So you could say, you could approximate the coverage of the Earth by saying that there's different hexagons of different sizes. So, we didn't come up with that. That's a well-known construct. So, those hexagon tiles can represent stuff. So those are interesting for us to calculate our coverage within a region, but I can't communicate to other humans in terms of hexagons. So we use map regions as a political boundary, as a way to talk with other people about where we're trying to go coverage. So right now there are some places that are parts of unexpected regions. There are places that are included in like sort of the default region. So when you're not included in a specific political boundary, Bay Area or Dallas Fort Worth or Denver area, so you can end up in a default region. So if you've seen that you've been mapping in a default region, it's maybe that you're outside of a major metro area.
Okay. And because these are incentivized, the whole process.
That's right.
Incentivized by hunt,
Yep.
right?
That's right.
So which is a crypto token that is based under Solana.
That's right. Yes. Yep. Yeah. So
Are certain regions incentivized more than others when you're areas you're trying to promote coverage in?
yeah. So let's talk about how regions relate to earning rewards. So I spend a lot of time in rural New England. That's where my family's from. So it turns out there's different demand in rural New Hampshire than there is in the Austin, Texas area. And there's demand that's based upon population, and there's demand that could be based on consumption need. So if a particular customer now all of a sudden has a need to map, remote Greenland, there should be a way for us to say, hey, Hivemappers in Greenland, let's get up to the north side of the island, and so having those areas allows us to do things like place bounties on particular area. That could be us, or it could actually be a third party. So if you're interested in promoting a particular area, there'd be ways to place boundaries on those. So that's really, really in terms of demand, right? And so demand can be any of those mechanisms I mentioned. Conversely, there's places where people just haven't described demand for them today. So if you're out driving in a place where nobody's described a particular demand, that's totally a thing. We're actively trying to grow a number of regions. You'll see that we're trying to grow coverage in South and Central America. That's really important for us. South Asia is really interesting to us. The reason for this is, this is cliche, but like San Francisco Bay Area is really well mapped today. Google's done a good job. Apple's done a good job. They're both based here. And so when we think about the importance of this device, we think about it has to be able to map other parts of the world that have not been as prioritized. And so that's really critical for us. So having these regions also helps us to think about mapping other parts of the world. I wish I had torn apart an HDCS for you today. I have one in the office. But if we do one of these again, we can get an HDCS and we can show you some of that hardware as well. So I mentioned we're a Raspberry Pi for the HTC. HDCS real quickly is based on a Luxonis Oak. So if anyone's familiar with Luxonis and Oak, that includes the Intel Movidius VPU. So the horsepower on that thing is really, really cool. Captures at like 30 FPS, records video while you're mapping, as opposed to streams of images. So yeah, super excited about that, and maybe we can do this again.
That would be great. You're always welcome on here. I guess we are kind of at an hour. This flew by today. Thank you so much for coming on, man. And I'm going to hit you up. I've still got a lot of questions. I'd
Awesome.
point that in here. But I would like to talk to you about the Wi-Fi and flashing this thing. And,
Yeah.
And, see where we can get there. But
Totally. Totally. Yeah.
I appreciate you coming on, answering questions. And you had mentioned earlier about the open source nature of this, and if developers wanted to build on the platform, they could just get to that from your website. So there's the dev links at the bottom, or there's
Great question. Great question. So, maybe reach out to us on Discord. I think there's probably some missing links in the documentation if you want to flash your own firmware. But if you follow Buildroot tutorials, it's Buildroot docs from there. So if you're on the call today, or you hear this recording later, definitely check out the Buildroot docs. And otherwise, happy hacking, and find us on Discord.
excellent. Nathaniel, thank you so much for being on. Everyone else, thanks for joining Hacks. I want to be respectful of your time, so we're went a little bit over, but we're wrapping up. Everyone be safe, and then we'll see you same bat time, same bat channel next week. See you, folks.